underlying concepts of it in circular economy, and also to be able to map the broad consequences of circular economy on giving emphasis on the biodiversity, human culture, health and well-being of all the species and human activities. And finally, to combine the characteristics of the energy systems and the strength of the circular economy. So just to recap what we have learned in this lesson 1, so we basically talked about the main principles, 3 principles of the circular economy. That is, the eliminate waste and pollution, circulate the products and materials at their highest value, and to regenerate the nature. So what exactly is a circular economy in simple words is that is a concept of waste simply does not exist. So moving beyond these principles, I just wanted to highlight the pillars of the circular economy. So there are basically 7 pillars of the circular economy, starting from the first one, which is on the materials, which are incorporated in the economy in such a way that they can be cycled at continuous high value. And we will be talking about each of them separately. And the second pillar is on the all energies based on the renewable sources. And going beyond that, the third pillar is on the biodiversity. So biodiversity is structurally supported and enhanced through the circular economy. And the fourth pillar is that is the human society as well as the culture. They are preserved through the circular economic approaches by applying into different sectors, not only focusing on the energy, but also the other sectors. And the fifth pillar is the health and the well-being of the humans as well as the other species is structurally supported through the circular economy. And the sixth one is about the human activities that generate the value in measures beyond just financial terms. And the last pillar is on the economic system, which is inherently adaptable and resilient. So what is meant by the materials are cycled at continuous high value. That is, a priority is placed on preserving the material complexity by cascading the materials in their most complex form for as long as possible. So the materials, they are not mixed in ways such that they are no longer can be separated and purely recovered unless they can continue to cycle infinitely at high value in their mixed form. So, and on the other hand, what we can do is we can use the materials that are used only when and where necessary. So that is simply meant by that pillar. And I told that the second pillar of the circular economy is all energy is based on the renewable sources. So the system is designed for the maximum energy efficiency without compromising the performance and the service output. So the materials which are required for the energy generation and storage technologies, they are designed in a way for recovery into the system. And on the other hand, what we can do is the energy is intelligently preserved and also it is cascaded when the lower values of the energy are available for use. And not only that, going beyond, we are talking about the density of the energy consumption that is matched to the density of the local energy availability. That is, in simple terms, we are trying to avoid the energy transport as much as possible. And the third pillar is on the biodiversity. So that is supported and enhanced through all human activities. That is a core principle of acting within a circular economy. That is to preserve the ecological diversity, which is a core source of resilience for the entire planet. So the habitats, especially the rare habitats that we have, they are not encroached upon or else they are not structurally damaged through human activities or the anthropogenic activities. And then the fourth pillar is the human society and the culture are preserved. So if you look into a circular economy, the processes as well as the organizations make use of the appropriate governance as well as the management models, and they ensure they reflect the needs of the affected stakeholders, and all the activities, they are structurally, the activities that are structurally undermine the well-being or else the existence of the unique human cultures, they are avoided even at a high cost. Thereby, they are ensuring the human society and also the culture are preserved. The fifth one is on the health and the well-being of the humans and the other species that is supported. So we are focusing on the toxic and hazardous substances that will be eliminated as much as possible. And in the transition phases towards this circular economy, they are minimized and they are kept in highly controlled cycle if the toxic and hazardous substances are produced. And whatever the economic activities, they are never threatened to human health or the well-being. So just a simple example that I have included here. So successfully recycling the electronic waste or e-waste by having people burn it over open fires. It is not considered a circular activity despite the fact that it is resulting in a material recovery. So if you're focusing on the material recovery, of course, you can go for that. But other than that, we are not encouraging or motivating this. So it's a simple example for that. And the sixth pillar is on the human activities generate the value in measures that is beyond just financial, as I mentioned. So materials as well as the energy, they are not available in infinite measure. So their use should be intentional and make a meaningful contribution to the creation of the societal value. So forms of value beyond the financial include like aesthetic value, the emotional values, as well as the ecological value. So these actually cannot be brought down to a common measure, and they must be recognized as value categories in their own right. So the choice of to use the resources maximizes the value generation across as many categories as possible. That is the target. And the final pillar is on the economic system. It is inherently adaptable and resilient when you have the circular economy. So adapt to change and to recover from the shocks. So if you have a circular economic system, they are not rigid. Instead, they are flexible and they are resilient. So flexible means they are able to respond to the changing resource availability and also with the changing technologies or the market demands. And on the other hand, resilient means they can withstand the disruptions like if there are breakdowns in the supply chains, or maybe due to extreme climatic events, or maybe due to the volatility of the price. So they are resilient. And the economic systems, or they should have a governance system, and also they should have incentives where they can incentivize, and also mechanisms in place that allow it to respond to systemic shocks as well as the crisis. I think that's all about those 7 pillars of the circular economy. So from here onwards, I just wanted to introduce you to different key areas where we can implement the circular economic principles. So I have just listed some areas, but I'm not going to talk about all the areas, but few main areas I will be giving an introduction. And I'll be providing you a list of references where you can further refer and get an idea about that. So the food and agriculture is a main area that you can implement a lot of circular economic principles and approaches. And the energy sector where your focus is mainly on. Not only that, the mining industry, electronics and the ICT, and textile and apparel sector, built environment, packaging and plastic industry, and the water as well. So just a few sectors where you can apply them along with examples. So if you look into the renewable energy sector, so what is the role of renewable energy in the circular economy? So if you look into renewable energy sources, we know that we have the hydropower, wind, solar, biomass, that is referred to as the danger power, and also the geothermal. So different energy sources, the highest contribution is from the hydropower, followed by the wind, solar, biomass, and the geothermal that I have included in this figure as well. And so if you switch to the renewable energy that can contribute to all 3 principles of the circular economy, as I mentioned at the beginning, so designing out waste and pollution, keeping the products and materials in use, and regenerating nature. So, but if you take the renewable transition, so this is particularly important to addressing the first principle, that is the designing out of the waste. So it can reduce the emissions and also the pressure on the natural resources, and they can map innovative pathways to net zero economies and create sustainable economic growth and jobs. And at the same time, they can reduce the supply chain risk. And the renewable energy technologies, they are often dependent on highly critical minerals like lithium, cobalt, and metals like nickel. So if we have the circular strategies, including to a great extent of the recycling, and also if you use the recycled materials, and also if you design especially for the second life, targeting for the second life, and also thinking of the disassembly, that will be able that will all be able, or that will all be required if we are to conserve these resources. And so as with anything in the circular economy, so if the materials and the equipment used by the renewable energy sources, they are reused, and also if possible remanufactured at its end of life, then it can reduce the environmental cost of the infrastructure that is required. So what the countries, the world have been working, they have been working for decades in improving the efficiency as well as reducing the carbon emissions of their energy systems. And if you look into a complete transition to a more sustainable energy system, that requires actually an innovative transformation. So you cannot have an overnight complete transition from the linear to the circular, but it needs more and more innovative transformation. So active engagement of the citizens in changing their consumption patterns for the materials and energies also require not only this innovative transformation or the technologies, but also we have to change consumption patterns, the mindset, and all should be gradually changed. So on the other hand, if you understand the local energy resources or the energy infrastructure and the local energy demand, so that we can smoothly transit to a circular economy in the renewable energy sector. And going beyond the alignment of the circular economy and the sustainable energy development processes, they locally can bring the opportunities for the cities in order to accelerate the energy transition, such as if you think of the waste to energy practices, where you can convert your waste to the energy, and also by integrating of the energy efficiency and renewable energy into the local energy systems. So those are some examples for that. And if you generally look into a system, energy systems, or what are the different or main characteristics of such energy systems, or we know that the energy systems are resources intensive, centralized, and so we'll be going through one by one. So they are resource intensive. That means the energy systems, they require vast amount of materials like copper, lithium, and some other rare earths. And also, they are largely depending on finite fossil fuels, mainly in the current economy, that is in the linear economic model. And we do have centralized and decentralized energy systems. We traditionally have centralized systems like powered from the coal or the nuclear plants. But we can also increase the shift to the decentralized systems, like you can have the rooftop solar systems, or else focusing on the microgrids. That is the meaning of the decentralized energy systems. And again, the high infrastructure lifespans, or the power plants, the grids, and the turbines, they are long-lived assets. And when you go for the decommissioning and repowering, they can generate large amounts of waste. And the other characteristic is the energy loss and inefficiency, that is the transmission losses, or sometimes the standby losses, and also inefficient end-use losses can be there. Not only the energy loss, but also we have concerns on the environmental and the social impact, where there are emissions, and also the habitat loss to a high extent, and the community displacement, especially in the fossil fuel models. And however, another characteristic of the energy systems is that it has a transitioning nature. So that means the global shift from the fossil fuels to the renewables, and sometimes we can think of the electrification of the mobility and transport, and also we can think of the smart system. So these are some characteristics of the energy systems. And if you try to identify the circular economy strengths that can be applied to these kind of energy systems. I have just created a table for you to get an idea or an overview of this. So if you look into the energy system challenge, uh, like depleting the finite fuels, so the circular economy strength is you can think of use of the renewable resources. So I have just given some examples in the third column. So we can focus on the wind, solar, biogas, and also nowadays the world is talking about hydrogen energy and the green hydrogen, etc. And the other challenge is the fossil fuel dependency. So we can think of the design for the closed loop systems. That is, we can think of the bioenergy from the agricultural waste. And then we have the waste from energy equipment, that is as a challenge for the energy system. And we can think of the circular economy strength like we can extend the product life through repair, reuse, and these kind of circular economy approaches. So that an example would be repowering the world wind turbines and also solar panel reuse, etc. So I have given some other challenges. I'm not going to read all of them, so I'll leave it for you to read. So we can combine the circular economy strengths and they can be applied to energy systems. This is what I wanted to highlight here. And so just some synergistic outcomes when you have the circular and the energy systems together. So the life cycle thinking, that means the circular economy promotes analysis from the raw materials where you can think of the use and reuse and recycle. So we can apply this to energy technology like solar panel life cycle management, and also think of the batteries second life, etc. And also we can think of the distributed and modular designs, or which aligns with the circular economy principle of local loops and the resilience. And we can think of the modular energy units like solar kits or microgrids, as I mentioned earlier. They are more adaptable, and also on the other hand, they are serviceable. And the energy efficiency combined with the material circularity, so it supports reducing the waste in both energy consumption, in terms of energy consumption, and also the material usage. So I have just given an example here, like if you take LED lighting systems which are designed for disassembly and again for the component reuse. And then about the core benefits with the nature, so the circular economy values regenerative design. I'll be talking about this regeneration and the designs, and then the integrating renewables with ecosystem restoration. So uh, I don't know whether you have heard about this agrivoltaics or agrovoltaics, where there is a dual land use for energy as well as in the agriculture, where you can install the photovoltaics, the solar panels on top of the agricultural land, so that the solar energy is used to a maximum, like the crop energy requirement is also fulfilled. At the same time, you can use it for the energy usage on the other hand for other applications. And this slide I just wanted to include where you can explore and learn about these kind of synergistic outcomes where you combine the circular and the energy system. So just some case examples that I found in the internet. One is on the battery circularity, and the second one is on the biogas from the agricultural waste. And I have given some examples highlighted in the blue color, and the smart grids and the demand response. So just read them and you can find more information about these kind of synergistic outcomes. And this is again another area where we can apply the circular economy, that is in the built environment, where we have the different buildings for different purposes. So we know that with the increasing urbanization and demands for the urban housings, or the cities, they become the hub for the waste that is resulting from the construction and also the demolition activities. So if you take a built environment, that is a key source of materials and which also poses great challenges for the circularity. And especially if you look into the construction and demolition waste, or C&D waste, that consists of diverse materials starting from the concrete and bricks and wood, metal, etc. So many of these materials, if you look into them, they are fit for recycling or else sometimes reuse, and they are having a high resource value. And if you look into the global aspects on the circular economy and the built environment, EU member state countries, they are recycling these building materials to up to 90% the construction and demolition waste, and other countries altogether, they are like 10% recycling rate. So if you take the materials in the older buildings, they are often unknown, or buildings are not assembled for reuse. But nowadays, the trend is towards designing the buildings or the building materials for the disassembly, so that they can reuse and they can maybe go for the adaptive reuse, etc. So once you implement the circular solutions, that means you are looking at the whole life cycle of the buildings and also looking at the whole life cycle of the building materials. So thereby they can manage the existing construction and demolition waste, or else they can prevent the construction and demolition waste through adaptive reuse. That means suppose you are getting some concrete from a building, so that once you demolish the building, so this concrete can be crushed and then they can be reused as a base material, maybe in the road construction or maybe in another new construction. And if you take timber, so that maybe the timber beams, they can be reused from an old building to an maybe to a new building as the interior design, or maybe in the flooring. And if you check the whole building itself, then we can also go think of the repurposing, where like as an example, so if you take an old industrial warehouse, that can be converted to an office or maybe into another application. That is the meaning of the adaptive reuse. So in those ways and means, we can create a future built environment without waste. And so on the other hand, if you have the circular economy, that could also reduce the global carbon dioxide emissions from building materials up to 38% in 2050. So it's a great contribution. And in these two links, I just wanted to give you more information about how the circular economy principles are used for achieving the net zero in built environment, etc., and also what is meant by circular buildings toolkit, so that you will be getting into know more about the circular economy and the built environment. If it is necessary and applicable for you, of course, you can go through them. And another application of the circular economy is in the textile and the fashion industry. So if you look into the current fashion model, or the fashion industry and the textile industry, so this is operating linearly. That means they are prioritizing the mass production and consumption of the clothing as well as the footwear. So they're mostly made from the fossil fuel-based synthetics, and they are not designed to be reused or recycled. I think in the first lecture also I talked about this textile industry. So this continuous cycle of overproduction and also the overconsumption within this linear system is actually fueled by the aggressive marketing approaches that they are using, and also they are having a lot of advertisements and also the persuasive power of the influencers. So as you know, the linear model, they are significantly contributing to the textile waste generation, and they are encouraging the disposal of clothing and footwear after minimal use, or sometimes when the trends shift, then again it is becoming as a waste. So these items, they often end up in the landfills, or else they get incinerated, they get burned, or else they are sent to the developing nations like African countries, Africa continent. That would be a good destination for this kind of waste. So where it is creating more and more environmental complications as well as the social complications. So if you recognize these kind of environmental and the social impacts, then the fashion industry could shift towards a circular economy. So we need to focus on the strategy for the textiles to strengthen the industrial competitiveness and innovation at the same time. And also we have to boost the market for the sustainable and circular textiles, including the market for textile reuse. We have to promote the textile reuse and create more second market for the textile. And at the same time, you have to address the fast fashion as well as driving new business models. Those are really important if you want to shift for a circular economy in the textile and the fashion industry. And another sector is on the water. So you might not think that the circular economy could be applied to the water sector, because we know water plays a crucial role in the circular economy, which aims to create a sustainable system where you can minimize the waste, maximize the resource efficiency, and promoting reuse and recycling. So once you apply the circular economic principles to water management practices, thereby you can significantly improve the water and energy efficiency and address the water and resource shortages. So in the context of circular economy, water management focuses on reducing water consumption, optimizing the water usage, and ensuring the reuse and recycling of the water resources. So I just wanted to give you some key aspects that you can consider in the when you apply circular economy in the water sector. So if you focus on the water conservation, there is where the circular economy promotes the efficient use of water resources by reducing the water consumption and minimizing the waste. So that means that involves like implementing the water efficient technologies and practices in the industries, in the agriculture sector, and municipal and household levels. So like if I give you a few examples, like you can use low flow fixtures, and also if you look into the agriculture sector, where you can use the efficient irrigation techniques like micro irrigation. You might have heard about the sprinkler irrigation, drip irrigation, such techniques are there. And also you can think of the water recycling systems. Give me a second. So the next one is about the water reuse and recycling. So instead of you treat the water as a single-use resource, then the circular economy that is emphasizing the reuse and the recycling of the water. That means you can treat and purify the wastewater for different approaches. Like you can apply this reuse like treated wastewater in the irrigation applications if in the case like it is not contaminated by heavy metals, and different other industrial processes, and also even the potable water production. In some countries they are using that application as well, but they are, if you use it as a drinking potable water production, then you have to think of the hygienic aspects, and then you have to continuously monitor about the water quality. And there are some advanced water treatment technologies like reverse osmosis, if you have heard about it, and the membrane filtration, and also there are some disinfection methods that enable the safe reuse of water. I think Singapore, they are using these kind of techniques and then producing potable water. And then about integrated water management, where the circular economy recognizes the interconnectedness of the different sectors and their water needs. That is where you can integrate the water management, like coordinating the water use across different sectors. You can take the agriculture sector, industry, as well as the municipalities. so that you can optimize the water allocation among different sectors, and then you can minimize the wastage. So what we can say is like you can promote the water sharing agreements between different industries, and also you can think of the decentralized water treatment systems, and also think of different innovative approaches like water sensitive urban designs. And at the same time, you can think of the nutrient recovery from the wastewater. So, because if you take wastewater resulting from different industries, it can contain valuable nutrients like nitrogen and phosphorus. So, in the circular economy, we can think of this recovery of the nutrients. That is, maybe you can think of different processes like the anaerobic digestion, and also we can think of the precipitation of these nutrients, and also we can think of the algae cultivation, which can be useful for in different other applications like food production or in the pharmaceuticals, etc. And we are also talking about the water energy nexus when we talk about the circular economy and the water. So that means the water and the energy, they are closely interconnected, and we try to recognize the importance of their efficient use. So we can think of different technologies which combine the heat and the power generation, where it can improve the energy efficiency in the water treatment processes. That is simply an example for the water energy nexus. Nexus means they're working together. And in addition to that, the renewable energy sources can be integrated into the water treatment facilities to reduce the environmental impact. And going beyond those things, we can think of the innovation and the collaboration. That is, using the circular economy approach to water management that can encourage the innovation and collaboration among different stakeholders, like various stakeholders, like you can think of the partnerships between businesses, government agencies, not only that, the research institutions, the academia, and also the general public, the communities, to develop and implement sustainable water management practices. So at different levels. So that on the other hand, it can promote the adoption of the digital technologies and like data-driven approaches, IoT-based technologies, where you can monitor the water consumption, efficiency of the water, and also the management of water. So if you adopt the circular economy approach to the water management, you can minimize the water scarcity, you can reduce the pollution, and also you can create a more sustainable and resilient water system. And so simply by adopting innovative technologies or maybe some other approaches, we cannot achieve this, but you have to have a shift in the mindset, as I mentioned in other aspects as well. And also the implementation of innovative technologies together. And also we have to bring all the practices so that we can have a sustainable model for the circular water management. So if you are looking for a circular water pathway, so the existing water systems, we know that they are very inefficient, and starting from the catchment, which is coming to the consumer or back to the catchment, what is lost and what is polluted, and it is wasted, and also it is misused. So the water pathway, the circular water pathway should be developed in a way that it is acting as a closed loop system with cascading water quality options determined and differentiated by use. So we can think of the upstream investments, that is through conservation and pollution control measures, or as utilities can reduce operating expenditure related to the treatment processes. Other than that, if you want to achieve a circular water pathway, We have some different other approaches like rainwater harvesting. Maybe you can apply this at a household or community level where it is contributing to demand management of main supplies and localized flood control, etc. And we have the grey water recycling for non-potable reuse. This is again applicable at the household or community level, and it can contribute to demand management of main supplies. And the treated water can be used for uh, different applications like toilet flushing, garden use, and also in some cases maybe used in the washing machines. And the grey water again can be used for agriculture and aquaculture. Mainly, you can use it at small scale, and that can also contribute to the demand management of main supplies. So, if you apply the grey water to the agriculture and aquaculture, so we have to exclude the detergent-rich grey water, which is resulted from the washing machines or the cloth washing machines, and also from the kitchens, because it can be harmful if you especially focus on the aquaculture and in some agricultural aspects. And then about the reused water for industry. So we have the water quality guidelines or standards for the reclaimed water for industry. They are not as strict as those for the drinking water purposes. So the reclaimed water, if you cascade this reclaimed water, that allows the lower quality water to be used in industrial applications, maybe for cooling processes, and also in the boilers, like domestic use water can be used mixed up with the pulp, and then paper can be recycled back into the pulp, and they can be applied in the paper mills, etc. And again, if you focus on the reduction in the water consumption, by reducing the water consumption at the domestic level, it can reduce the need to produce more potable water. And this can be achieved through promotion or like by giving more awareness, and also through maybe you can do the awareness by awareness campaigns, or by maybe institutions like National Water Supply and Drainage Board, where they are doing their water metering. They can give more awareness to that. There you can reduce the water consumption as well. And I think that's all about the different applications of the circular economy in different sectors. So from here onwards, I just wanted to discuss about the industrial symbiosis, eco-design, such key features of the circular economy. So this is about the eco-design in the circular economy. You might have heard about the word. So eco-design or the ecological design is defined as any form of design that minimizes or that focuses on environmentally destructive impacts by integrating itself with the living processes. So mainly the eco-design considered the sustainability from the very birth of a product, and how you can reduce the environmental impacts more effectively. So when you take an eco-design, we are placing the ecology in the foreground of the design, and it provides specific ways where you can minimize the energy usage, the material usage, and how you can reduce the pollution, how you can preserve the habitat, and how you can foster the community health as well as the beauty of the nature. So that means it provides a new way of thinking about your design. So it actually enables innovation by integrating the environmental impact as early as possible. That means at the design stage itself. So this eco-design is measurable. That means it is, I mean, the sustainability is commonly conceptualized as resting on the three pillars. That is not the pillars of the circular economy, but the three P's or three pillars. That is the people, focus on the society, planet, and the profit. At the same time, we are focusing on the profit. Like we are not only focusing on the people and the planet through eco design, but also we have to target for a good profit. So as I mentioned, so it is focusing on minimizing the product's environmental impact When you talk about the eco-design, that it has, we say that it has two siblings. That is, it is having a circular design within its design, and it is not only a circular design, but it's also a sustainable design. So the circular design concept emphasizes there is no raw material extraction and no waste measures, aiming to keep the materials in the economic loop as much as possible. Sustainable design means it encompasses both eco-design and the circular design, and also it adds the social dimensions or the social considerations. So rather than talking about eco-design, I thought of giving you an example. There are many examples for this eco-designs applied in the circular economy. So this is just a relevant example for you. That is a recyclable wind turbine blades. So this is introduced by the Siemens Gamesa, that is known as a recyclable blade. So here what is eco-design is, that is, the traditional wind turbine blades, they are made with the composite materials, like taking the fiberglass and different epoxy resins. So which is, when it comes to recycling, it is very hard to recycle. So what the Siemens Gamesa have done is they have developed a new resin system that allows the separation of the materials at the end of its life, and so that it is enabling the fully recyclability. So this is a very simple, not a very simple, but a very easy example for you to memorize. And so you have all the information in their websites, recyclable blade. You can just Google and find more information. And the eco-design principles, if you take the principle one, like design for end of life, so this is actually related to the previous example. So the application in the wind blade is like materials can be separated and recycled after decommissioning. And the other principle in this eco-design is use of non-toxic materials, because it's eco-friendly resin system that they are using, which is replacing the toxic bonding agents. And they have also thought of the modular thinking, because the blades can be disassembled at the end of its life, and they can be easily handled, and efficient handling is ensured, and the minimizing of the resource depletion, that is the reuse of the recovered fibers and materials in the new product. I think it's very clear for you. So why it is important to have an eco-design circular economy? Because there are many benefits. If you focus on the energy sector, it can reduce the landfill waste generation from decommissioned blades, and it saves the raw materials and lowers the carbon footprint of manufacturing, and also it supports a circular economy model in the wind energy infrastructure. So that is just an example from the wind energy. And I think that's all about the eco design. And this is about another area that is called the industrial ecology. So industrial ecology, before I talk about the industrial ecology, so I thought maybe I should talk about what is an ecosystem that is naturally available or naturally in the surrounding of us. So the definition for the ecosystem is, that is the complex of the living organism and their physical environment in the surrounding and all their interrelationships in a particular unit of space that is taken as a whole, and then we refer it to as an ecosystem. So just a few examples for an ecosystem is, like if you take the forest, so it is considered as an ecosystem, maybe the grassland or maybe the tundra system ecosystems, and also again the desert is an ecosystem. So if you look into these natural ecosystems, they can be categorized into abiotic constituents. Abiotic means the opposite of the biotic, that is non-living. So like you can have the minerals, you have the climate, you have the soil, water, sunlight, and all these things, the non-living elements, and also you are having the biotic constituents. That is all the living beings like animals, plants, and human beings, everybody. So that is the composition of an ecosystem which is naturally there. So if you try to link these constituents together, there are two major forces. That means the flow of energy through the ecosystems and the cycling of the nutrients within the ecosystem. So the ecosystems can vary in size, and there are small ecosystems. And even if you take a single water droplet, you can have an ecosystem inside that. And also we can have large ecosystems like deserts and all. But going beyond these natural ecosystems, when you talk about the industrial ecology, then they are trying to conceptualize the industry as a man-made ecosystem, and which operates in a similar way to that of the natural ecosystems, where the waste or else the byproduct of one process is used as an input into another process. So this is how this industrial ecology came into play in the circular economy. So in the industrial ecology, what happens is it interacts with the natural ecosystems and attempts to move from a linear to a cyclical or a closed loop system. So in the industrial ecology also, we are studying about the material flow and also about the energy flow, how this can happen through the industrial systems. And what are the main features of the industrial ecology? So if you take the industrial processes, starting from the material extraction through to the product disposal, product development and disposal, they are having an adverse impact upon the environment at each stage. So what we are trying to achieve through the industrial ecology is we are aiming to reduce the environmental stress caused by this industry while encouraging the innovation, resource efficiency, and the sustained growth. So in the industrial ecology, that is acknowledging that the industry, they will continue to operate, and at the same time they will expand, however, and it supports industry that is environmentally conscious and has less burden upon the planet. So what happens in the industrial ecology is they are trying to each and every industry maximum possible, they are trying to interact with the nature and try to utilize the waste and the byproducts of the other industries as inputs and try to bring it into their own processes. So this is what is simply meant by the industrial ecology. And this is operating under few principles. So they are trying to create industrial ecosystems, trying to close the loop. That means weave the waste as a resource rather than considering it as a waste. And then try to create the partnerships with other industries to trade byproducts, whatever the products that they are generating as a waste, and they can be used as the input to the other processes. And at the same time, they are trying to balance the industrial inputs and outputs into the natural levels and manage the environmental industrial interface and increase the knowledge of the ecosystem behavior and try to recover the resources and recover time and capacity, etc. And also, they are talking about the dematerialization of the industrial output. That means where you can use less virgin materials extracted from the earth, and also focusing on the energy by becoming more resource efficient and also by reusing materials or try to substitute more environmental friendly materials. That means simply to do more with the less. And they are also focusing on the energy use, maybe by incorporating the energy supply within the industrial ecology to go for the alternative sources of energy that can have less or no impact upon the environment. And also aligning the policies with the industrial ecology concept. That means incorporate the environment and the economics into the organizational, national and the international policies, and use economic instruments to encourage a more move towards the industrial ecology. And what are the benefits of the industrial ecology so that you can easily understand? It saves a lot of costs. So where you want to put on the material purchasing or licensing fees can be reduced, and the waste disposal fees that can be reduced, and then there you have a large cost saving to the industry. And on the other hand, in terms of the environmental protection can be guaranteed, and again you have the income generation through selling of the waste to another industry, or as if you have the byproducts you can sell them and there will be another income generation. And again, as a corporate image, so that will be enhanced, the corporate image would be enhanced, and there will be improved relations with the other industries and the organizations, and also there will be market advantages. However, even if you say that there are so many benefits of the industrial ecology, it's not that easy to apply, because there are many limitations of the industrial ecology, like lack of support from the government as well as from the industry. They might be reluctant to work together, and for different reasons. And also the reluctance of the industry to invest in appropriate technology. Even if you want to go for the industrial ecology, maybe you might need to have a separate technology, so that to spend more money they might be reluctant. And there could also be some perceived legal implications, and again reluctant to move to another supplier. And there will also no market for the materials. That those are the main limitations of the industrial ecology. And I think that's not needed. And there's another concept when we talk about the circular economy, that is called the industrial symbiosis. That is, symbiosis means it is a term describing any kind of relationship or an interaction between two dissimilar organisms. Maybe the specific kind of symbiosis depends on whether either one organism would benefit, or maybe both organisms would benefit from this kind of relationship. So if you get a coral reef in the ocean, so that's a very good example for symbiosis, where two organisms would benefit each other. And so when it comes to the industrial symbiosis, that is the process by which the waste or else the byproducts of one particular industry, or through one particular industrial process, becomes the raw material for another. So if we apply this industrial symbiosis, that allows the materials to be used in a more sustainable way, and it can contribute to the creation of the circular economy. So it's actually industrial symbiosis is actually a subset of the industrial ecology. So it mainly describes how a network of diverse organizations or diverse industries, they can foster eco-innovation and long-term culture change. They can create and share the mutually profitable transactions, and they can improve all the businesses, and at the same time they can improve their technical processes. So there are various benefits through the industrial symbiosis for the business, for the communities, and also for the environment. The main benefit is the reduction of the waste and the pollution, so where you are reusing the resources. So the businesses can minimize their environmental impact, and they can decrease their dependence on the virgin raw materials. And as I mentioned, you can also reduce the potential cost savings. The potential for the cost savings, and because where you are sharing your resources, the business or the industry can reduce the expenses, and they can improve their bottom line. And also, industrial symbiosis can create new revenue streams by turning their waste products into the valuable resources. And this can also lead to new job creations, and as a whole, the economic growth could be improved. So simply, the industries can work together, they can develop their business, and then they can create new products as well as the services, so that they can sustain in a better way by getting more profit as well. And there are many challenges for the implementation of this industrial symbiosis. There are so many books written on the industrial symbiosis, so you can read all them and get more idea about how this industrial symbiosis is implemented actually in different countries. So in general, what are the challenges for the implementation of industrial symbiosis is the collaboration and the coordination among businesses. That is really, really challenging because the industrial symbiosis itself that requires a high level of trust and the communication, better communication between the different entities involved, different industries involved, and they should have a willingness to share the information, share their resources, etc. And on the other hand, we need to have a regulatory and the policy support from the government. So the governments can play an essential role in creating supportive policy environment for these potential industries where they can operate in the industrial symbiosis. Like they can provide the financial incentives and or as they can streamline the regulatory processes so that the industries would motivate to work together. So this is just an example for an industrial ecology or industrial symbiosis where it is successfully happening in, I think this is happening in the Netherlands. So this is known as the Kalundborg Eco-Industrial Park. That is the first full realization of the industrial symbiosis. There are different industries operating and working together. So this is actually, I think, okay, so this has several industries. That is, they're having a power plant and an oil refinery and a pharmaceutical company, and also at the same time they are having a fertilizer plant in an industrial park. So these businesses, they have developed a network among each of them, and they allow them to exchange the resources and to reduce their environmental impact. So for instance, the power plant at this Kalundborg produces steam that can be used to heat the buildings at a nearby pharmaceutical company. And the excess heat from the power plant that is also used to dry the sludge from the wastewater treatment plant in the park, which is then used as the fertilizer. The sludge can be used as a fertilizer at the nearby agricultural field. So this is how all these industries are operating and get the benefits. So in addition to that, the wastewater from the pharmaceutical company that is treated and that is used as processed water at the nearby oil refinery. So I think you can understand what is the industrial symbiosis and how it is successfully happening in different countries. So other than that, there are so many other examples you can take from the Europe and learn whether you can apply this into our scenarios as well. So according to the available statistics and information, so they say that this can save like 24 million euros in bottom line savings, that is annually. Other than that, there is also like the savings of the carbon dioxide and also this much of water savings are resulted, and also there are energy savings and solid waste savings, etc. So this is a very good example where you can think of the environment, planet, and also how you can make profit using the industrial symbiosis. And from here onwards, I think I just have like 20-30 slides about the circular economy indicators. So main indicators that we talk under the circular economy. So the first indicator is where you can monitor the progress towards a circular economy. So these indicators are useful. We are talking about the production and consumption. So this area is having 4 indicators like self-sufficiency of raw materials, green public procurement, waste generation, and food waste. Those are the 4 indicators. And then we have the other 2 indicators. I think I've been mentioning about this in the first lecture as well. So the other indicator is about the waste management, that is having two indicators, recycling rates and the specific waste streams, etc. And then we have the secondary raw material usage, that is having two indicators like contribution of recycled materials to raw materials demand and trade of recyclable raw materials. And the fourth one is on the competitiveness and innovation, that is having two indicators, private investments, patents related to recycling and secondary raw materials. And this is another area that we mainly give the emphasis on in the circular economy, that is about the biodiversity. So biodiversity is a term used to describe the enormous variety of life on the earth. So it can be used more specifically to refer to all the species in one region or in one ecosystem. That means it is referring to every living thing, including plants, bacteria, animals, as well as humans. So if you take the current situation, much of the Earth's biodiversity is in threat, that is due to the human consumption and other activities that disturb and even destroy the ecosystems. So pollution, the climate change, and the population growth, they are all considered as a threat to the biodiversity. And this has caused due to the unprecedented rise in the rate of the species extinction. And scientists have estimated that half of all the species on Earth will be wiped out within the next century. So that the conservation efforts are really, really necessary to preserve the biodiversity and protect endangered species, and also not only the endangered species, but also the habitats of them. So what are the key drivers of the biodiversity loss? We have the habitat loss, that is impacting the biodiversity by reducing or fragmenting the space and provisions ecosystems need to thrive. So this is a leading cause of species extinction. And the overexploitation, that means that impacts the biodiversity by removing more wild plants and the other species than the ecosystems which can replenish. That is, maybe you are overfishing or sometimes overuse of the water. And the other key drive for the biodiversity loss is the climate change. So it impacts the biodiversity by affecting the species' ability to survive. They are very much susceptible, and because this happens through a series of complex interactions, both among the species and between the species and their habitats. Then we do have the pollution as another key drive for the biodiversity loss. So there is in various forms which impacts on the biodiversity, causing loss of species and ecosystem dysfunction. That is, if I give examples like leaching of the fertilizers, which is leading to the eutrophication of the watercourses. That means if you have excess amount of nutrients, that can lead to algal bloom in the water bodies. That is meant by the eutrophication. And we do have the invasive alien species, which can impact the biodiversity by threatening the native species. So those are the main key drivers of the biodiversity loss. And if you take at present today, more than 90% of the biodiversity is lost in that is due to the extraction and processing of natural resources. And according to the recent research, they indicate that the food, the construction, the energy, as well as the textile sectors account for approximately 90% of the pressure on biodiversity worldwide. To halt and reverse the biodiversity loss, we need to fundamentally transform the way we produce, the way we use, and at the same time, where we consume our products and the food. So by transforming our current production and the consumption systems, so it is essential, it is an essential part of reducing the pressure on the biodiversity and the ecosystems. So going beyond that, more emphasis on the biodiversity. So there are a few areas of the circular economy that can benefit the biodiversity. Like if you reduce the primary resource demand, that can be achieved by increasing efficiency of our resources and materials use. So through circular economy actions, like we can extend the product's lifespan and also recycle the materials, and we also can prevent the pollution, where you can focus on preventing materials from ending up as the waste. And then again, biodiversity friendly sourcing, that is focusing on the resources we do use and which need to be sourced in a way that it can avoid harming the natural systems, and we can promote the regenerative practices where possible. So this is a chart showing the biodiversity, the level of global biodiversity, and today, as of today, and how it can change with time. So if you have the business as usual, that means if you have the current linear economy, you can see that the area covered under black color, that is the level of global biodiversity, is decreasing. And then, if you have the increased conservation and restoration efforts, so that you can have a certain level of global biodiversity achieved. But if you try to transform the production and consumption systems through the circular economy approaches, you can see that there is a level of increase how the biodiversity can be increased at the global scale. So it is really important that you think of the biodiversity in terms of circular economy, so that you can do a lot and contribute to the environmental conservation. And so if you take each principle of the circular economy, that can have positive impact on the biodiversity. So if you take the first principle, that is on the elimination of waste and pollution, so that to reduce the threats to the biodiversity, that is when we take the circular economy that is driven by the design, so the waste and pollution are eliminated, so these direct threats to the biodiversity can be reduced. For example, if you take like eliminating the unnecessary plastics, and if you think of the redesigning plastic products to have like post use value, so for reuse in recycling or maybe composting, that means they can circulate in the economy rather than being wasted and polluting the environment. And if you take the food industry, so you can adapt the practices for regenerative outcomes that can reduce or eliminate the need for synthetic fertilizers, at the same time pesticides and other inputs that can harm the biodiversity. And the fashion industry, so that you can design the clothing that use non-toxic dyes, and like you can safely biodegrade the fabrics, and there will be no leakage of the hazardous substances and the microfibers into the environment, into the ocean. And focusing on the plastic packaging, you can eliminate the non-essential packaging items like one-time use plastics, single-use plastics, and other packaging, so that you can, you can reduce the threat to the biodiversity. And the second principle is on the circular products and the materials, where you can leave room for biodiversity. When the products as well as the materials are circulated in the economy, the need for the production from virgin material is reused. A good example is in the fashion. So we can think of the business models that keep maybe the cotton clothing in use for longer period of time, by assuming the purchase of new clothes is displaced, that will reduce the amount of land needed to grow cotton. So that can leave more space for the users, and you can preserve the wilderness areas as well. And focusing on the built environment. So if you design the buildings to make use of reusable modular concrete components, that can reduce the demand for sand extraction and because this can harm the local wildlife populations, and also it's occurring at rates beyond those that can be naturally replenished. And the durable goods, you can use the recycled metals and which is available in the electronic devices. That means you need less metals to be processed from an ore, and also you need fewer mines to be dug. Thereby, you are leaving more room for the biodiversity and avoiding the greenhouse gas emissions and also pollutions which are associated with the metal production. And the third principle of the circular economy, that is the regenerate nature. That means to enable biodiversity to thrive. So whatever the economic activity can and needs to actively rebuild the biodiversity. So if you take an easy example, if you take the regenerative agricultural approaches like agroforestry, where you are not harming the forest, but instead you're using the same land, and then you go for the agriculture as well, so that you manage the grazing and you are doing less damage to the soil, and the soil cover is there, and then the carbon sequestration in the soil is ensured, and you are not polluting the surrounding, and also you increase the biodiversity in the surrounding systems, so that the agricultural land could be remain productive at the same time, and then you are protecting the environment as well. And then if you think of the food and the material production at sea, so you can shift from the extractive practices to models that can proactively enhance biodiversity. Just an example is like if you grow, or if you think of growing the shellfish and also the seaweed in a vertical ocean farms, so that you don't have to damage the sea, or you don't have to use a lot of these kind of resources from the sea, so that can create kind of healthy agroecosystems that at the same time filter water, and it can absorb excess nutrients, and also that can capture carbon while producing food, animal feed, and also the other biomaterials. And when we focus on the forestry, so if you draw from on the forest management approaches like continuous cover forestry, that means you are not removing the top plant cover in the forest, and you are trying to employ the practices like using mixed stands. That means using different types of crops in the same area, and like sparing veteran trees, like the ancient trees can be kept as it is, and also you can leave the dead wood that can help to create the timber production systems that can gradually regenerate the biodiversity, and then there will be less destruction, or for the habitat disturbance is minimized. And at the same time, the water quality is maintained, and also it will improve the soil health because you are ensuring that the favorable microorganisms will remain in the soil. So in summary, what I wanted to tell you is there are key features of the circular economy, that is design out waste and pollution, and key products and the materials in use, like use in reuse, refurbishment, etc. And we are trying to regenerate the natural systems and try to harm the natural system to a minimum level, and try to integrate the renewable energy, and again we try to regenerate the soil, and again we are thinking as a system. So systems thinking is enhanced or motivated through the circular economy. And so other than that, we are talking about the closed loop. So waste from one process becomes an input to another, and how we can retain the value retention, where you can preserve the energy, labor, and materials that is already embedded in products and infrastructure. And we have tried to promote the upgradable and modular systems in different disciplines. And the business model innovation, that means where you can shift towards leasing, sharing, and product service systems. And also, we are talking about the performance-based model. So you will be learning about these in the coming lectures. And again, use of renewable energy. So circular economy supports and relies on clean energy sources. So those are the key features of the circular economy. And even if you say that circularity is a circle, but circularity is not a perfect circle. So often when people think of moving from the linear to the circular business model, they picture like one large continuous circle for their material flows. But in many cases, the circular business models, they do not operate in a perfect, such nice closed loops, because the most of the circular business models can be thought of as cascading flows of materials. If you can remember the butterfly diagram that I explained in the first lecture. So there I gave an example from a biological material where you can cascade, like if you take a textile, so that this textile or the clothing can be used as a rug, and then it can be used as a stuffing material and so on. So most of the business models, they are operating as a cascading flow of materials, not in a perfect circle. And they stay and they use, but they move across the value chains and the industries as a material quality or the market needs that can be changed. So the quality of the material could be changed, but they are not operating or circulate in a perfect circle. And so this circularity, actually this concept that require a paradigm shift in thinking about how a particular business model can and they should operate as restructuring corporate strategy. So in order to fully embrace the circularity, we have to reconsider of the multiple aspects of a company's business model, including the design, the manufacturing, distribution, use, and finally disposal at end of life. That is really, really needed. So companies, they must reimagine how their supply chains could be organized in order to reduce the risk when they shift to this circularity. So that is not, the circular economy is not a one size fits all approach, because there is no one size fits all approach to achieving the circularity. So because it is an ongoing process, unique to each company, unique to each industry, that will continue growing and improving over time. So as I mentioned, it does not happen overnight. So each company have their own paths to circularity that start with making the decision to pursue a circular business strategy, moving away from this so-called traditional linear economy. So the circularity can seem like an impossible end goal, but there are strategies that available to help you start and move towards a circular economy. So, if we look into the circular economy business strategies as a final step, so you can think of product as a service. So that is focusing on leasing access to a solution instead of selling the ownership of a product. Like if I give you a very simple example from the chemical industry, suppose now you want to purchase a certain chemical where you want to apply and clean a maybe surface. And what you can do is, maybe if this particular chemical is available in large volumes, large quantities, so that once you use it, maybe you need a small quantity. Like, okay, this bottle will be coming as 1 liter or 500 milliliters, but you will be required like 10 milliliters, I would say. So rather than purchasing this entire product, what you can do is you can get this service from a company who are manufacturing this particular chemical as a service. So this is like chemical, you are leasing just the service, but you are not going to purchase the product. So this is meant by the product as a service. And then you are embedding the intelligence. That means a company with this circular business strategy they can build technology into their materials or product together, use data, and then they can improve the customer experience. And then you can have the product life extension so that you can make sure a product is used for as long as possible by repairing, remanufacturing, or maybe remarketing materials. And when you select the materials, so you have to have the smart material choices. That means you consider a product's end of life treatment when choosing the materials. That is, for instance, would choose recycled or recyclable or biodegradable materials when you are designing a particular product. That would be a very good example. And also, you have to think of the closed loop or take back system. That means the business can provide a service to collect whatever the old or maybe the used products, and they can recover the value in the materials by recycling or reusing them to make the new product or the same product. So I think that's all for today's lesson. So these are the references that I have included. So there are a lot of information in these links, and the Ellen MacArthur Foundation. So I'll be sharing all this along with the recording. And I think that's all for today's lecture. So we are remained with like 5 minutes. If you have any burning questions, you can ask. Otherwise, maybe it is possible that you write an email to me or else make a phone call, or just even in the LMS itself, you can post some questions and you can send the messages. You can share your ideas, and I will be sharing, or I will be replying depending on your request. I think you might have received an email from the coordinator regarding the forming of the groups as well. So do you have any questions, urgent ones, where you need a response from me? If not, I think we can conclude. So I'll be sharing the recording as well as the presentation in the LMS. Is the group assignment already published in the LMS?
Not the assignment, madam. They asked to form the group only.
Yeah, this is just to form the groups only, yeah? So I think we have not shared the group assignment, so that will be basically last time we gave a case study where you had to work on as a team, like if I remember correctly, we gave an example like if you want to shift the Sri Lankan or a particular country's economy, if you want to shift from the linear to the circular economy in the energy sector, and we were asking about the policies, I think, what kind of policies should be developed and so on. I don't remember exactly. So you will be getting a case study or a question where you have to work, where you have to discuss, no, not to just take from the internet and work on it. So where you have to put your, input should be coming from you as a group. That would be something to think and write. Maybe to develop a policy related to energy sector or something like that, where you can apply what you have learned in the lectures, focusing on the circular economy and the energy.
Madam,
So
will you discuss the assignment in the coming session? So
yes, I think we will be publishing the assignment in the LMS. So if you have any questions related to the assignment, you can post or you can talk to us. So like if you need an explanation or clarification, of course we can do it.
okay,
I mean, usually when you get the assignment, you will be getting more details, how to structure it, how to write the report, and all these information, and the mark allocation will also be given there. But apart from that, if you have any concerns or clarifications are needed, of course, we can do it. So if you look into the Sri Lankan framework, so we don't have a separate policy for circular economy, but if you look into different policies and the acts and all, like environmental act and all, they have included some aspects which regard to the which is considering the circular economy, different ways it is addressed, but we don't have a separate circular economy policy. But I think we do have a roadmap developed for the circular economy. I don't remember, but I'll check it and let you know. So you can send an email asking about the questions, clarifications to me, and I'm ready to answer those questions. Or else, if you have any discussions or anything, you can post it in the LMS as well. There's a separate place, and also if you want to have discussions among the groups, you can have such discussions separately in the LMS. That facility is also there. So I'll try to provide you some extra reading materials so that you can have a better understanding. I know within this limited time you can't understand and you can digest everything. So, but the assignment would be basically on for you to think and write, have a discussion, would be an advanced assignment. Okay, so
Excuse
I
me,
think we
madam.
yes.
In the activity diary, there was a particular mention about an assignment due date on like 6th June.
Mm-hmm. Yeah, it's okay because the activity diary was previously scheduled, so there could be changes. It's okay.
So that assignment submission will be on 19th July, madam. Has it been changed?
I have to check that actually. Then I'll
Okay,
check
madam. Thank you.
because the whatever you have received, so there are in some courses there are changes. So there might be changes. So you will be getting sufficient time for you to complete the assignment. Don't worry. Like 2 to 3 weeks time, you will be getting. So I think I'll talk to Ruchira and see. I mean, within the assignment itself, you will be getting the deadline and everything. So don't worry on that.
Okay, madam.
There's a question asking about any programs from international donor agencies like ADB or any organization such as UNDP targeted to support circular economic transition of developed or underdeveloped countries. As far as I am aware, I don't think that there is such program, but I can check. Maybe there are grant schemes, not only targeting the circular economy, maybe targeting the sustainable development goals. So this is again coming under sustainable development goal. So I think there is a grant call recently. So the deadline is like 30th of June. That is focusing on the SDG partnerships with the Germany. So if any of you are interested, you can think of applying. But there should be a partnership with a German university. That is a must. That is a requirement. So you have to talk to a German university and then work together and develop a proposal. So in that case, you can focus on this kind of circular economic transition or in the energy sector or any other sector. Okay, there's another request. So you need more time to discuss on the assignment. Of course, yeah. So I didn't finalize the assignment yet. So once we finalize the assignment and once we post it, so you just go through the assignment and see whether you can understand it or as if you need some clarifications or a discussion. So we'll have short one. So what I can tell is like you have to think and write. So that would be bit advanced assignment. Okay, if there are no more questions, I think I'll conclude, and thank you very much for your participation.
Thank you, ma'am.
Thank you.
Thank you.
Thank
Thank you,
you,
madam.
Thank you, madam.